Good evening. Thank you for coming to listen to my presentation on Stephen Hawking. Will just most likely be my professor. I do want to give a little forewarning. I will be saying the names and titles or whatever is appropriate for each of the sources. As you can tell at the bottom, some of the titles for the photos are a little lengthy, so forgive me if this presentation is a little lengthy in itself, but I'm going to get through regardless. Let's begin. Stephen Hawking, world-renowned 20th to 21st century theoretical physicist. My goal is simple. It is a complete understanding of the universe. Carr et al. The photo says, credit the Franklin Institute, courtesy AIP, Emilio Segre, Visual Archives, Physics Today collection. That was the title of the picture from where I got it. There was nothing else, so let's continue. Early life. Stephen Hawking was born on January 8, 1942, to Frank and Isabel Hawking. Frank Hawking was a doctor who specialized in tropical diseases. His studies would on occasion have him travel to Africa. He had attempted to serve during World War II, but Frank was given the decision from his superiors that he should continue his medical research. Isabel Hawking had a variety of careers after obtaining her degree from the University of Oxford in economics, politics, and philosophy. Photo, Stephen with his parents. Early life 2. Stephen's family had initially lived within the area of Highgate in London. Stephen's family had decided to move away from London whenever possible due to the threat of the German Blitz, bombers flying across the English Channel that would have dropped bombs on London. When Stephen's family had moved from Highgate to St. Albans, Stephen's first school there was the St. Albans School for Girls. The school would educate boys up until the age of 10. Photo, Stephen aged 12 in 1954. Flip those. Early life 3, primary school. Since the St. Albans School for Girls would only take boys until they turned the age of 10, Stephen had to take his 11+ exams a year earlier than usual. The rest of Stephen's childhood education was undertaken at St. Albans School for Boys after he finished his exams. Stephen was not a star pupil in his class. His grades normally brought him to the middle range of the class. Even though Stephen was not currently the brightest in his class when it came to grades, his classmates called him Einstein, as they clearly saw the signs of genius in him missed by his teachers, Stephen Hawking. Early life 4, final years of high school. Bear with me as I get my mouse out of there. During his junior and senior years in high school, Stephen developed an interest towards mathematics and physics. Stephen's father had already been teaching him mathematics in his spare time. Now, Stephen was being taught by a brilliant mathematics teacher, Vikrant Tata, R. et al. Thanks to Mr. Tata, I became a professor of mathematics at Cambridge, a position once held by Isaac Newton, Carr et al., said Hawking. After graduation, Stephen had to decide on which institute of higher learning he should consider enrolling in. His father had been very persistent of both applying to Oxford, where Frank Hawking had graduated, as well as having Stephen pursue medicine instead of mathematics or physics. Frank Hawking's reasoning was more along the lines, medicine is much more lucrative than mathematics. Stephen and Frank Hawking concluded with a deal that Stephen would go to Oxford, but he would major in natural sciences. Stephen passed the entrance examination at the age of 17. Photo, Stephen Hawking pays tribute to his teacher, Vikrant Tata. Opened it on the side here. Let me close that. Education, Oxford. Hawking's experience at Oxford was not turning out to be as stimulating as he may have wanted it to have been. Work, from his perspective, was not a completely encouraged activity. Stephen says, to work hard to get a better class of degree was regarded as the mark of a grey man, the worst epithet in the Oxford vocabulary, R. et al. As this was a new location for Hawking, he felt socially isolated. To remedy this, he joined a rowing team as a cox. His performance wasn't particularly distinguishable, but this did remedy his lack of socializing by making new friends. Photo: Stephen as cox of the University College, 7th at Oxford. Hope I'm saying that correctly. Education, Oxford 2. As mentioned, work was not a concerning activity to engage in. Hawking was no different and performed minimal work, but his genius was recognized just as it had been seen by others at St. Albans. During Hawking's final exams, he did not pay much attention to factual knowledge questions, instead looking towards problems that dealt with theoretical physics. Hawking obtained a degree that balanced between being first and second class. To determine which class Stephen's degree should be, Hawking was scheduled to appear before a panel of examiners for an interview. Stephen told them that if he got a first, he would go to Cambridge to do research. If awarded a second, he would stay in Oxford. He was awarded a first. Carr et al. Education, Oxford a third. 3, whatever. Before Hawking had advanced beyond Oxford, his lifelong ailment began to show. He had such difficulty with movement of any kind to the point where he couldn't even tie his shoelaces. The initial checkup for Hawking was established as a result of an ice skating incident. Hawking had toppled over, but he was unable to get back on his feet. A month after Hawking's 21st birthday, he was given the results of tests to investigate the cause. Currently, we know the disease to be amyotrophic lateral sclerosis, or ALS. In the United States, ALS is also known as Lou Gehrig's disease. ALS was not known at the time Hawking received his tests, so he was told that this unknown disease was both progressive and incurable. The original prognosis said he only had 2 years left to live. ALS. Upon receiving results of the tests, Hawking's heart sank and he became depressed. Despite the terrible news, Hawking had several sources to keep him inspired. His love, Jane Wilde, whom he had yet to marry, and the music composed by Richard Wagner, for example. Photo: Stephen Hawking was married Jane for 30 years before their divorce in 1995. That was word for word. I don't know if that's English, but they definitely missed some English in there. Education, Cambridge. Hawking began his education at Cambridge in 1962. He was hoping he would study under the famous astronomer Fred Hoyle, but unfortunately, Hoyle was advising too many students at the time to take any more on. Instead, Hawking had the luck to have been supervised by British cosmologist Dennis Sciama. Hawking had no idea who he was at the time. Sciama was enthusiastic about his field and supervised other students that later down the line had made quality contributions to the field. Interestingly enough, Hawking's first paper disproved a theory of Hoyle's. Hawking had publicly challenged Hoyle at a Royal Society meeting in 1964. When Hawking informed Hoyle of certain flaws within his theory, Hoyle asked, "How do you know?" And Stephen answered, "Because I calculated it." Carr et al. Education, Cambridge 2. In 1965, Hawking had finally obtained his PhD. His thesis was titled Properties of Expanding Universes. Afterwards, in pursuit, he applied for a research position at Gonville and Caius College in Cambridge. That same year, he was accepted. Hawking had begun yet another paper of the existence of singularities in spatially homogeneous and anisotropic world models. Carr et al. Forgive me if I can't read these the first go. Papers. During Hawking's time, cosmology, amongst other fields, had reached a considerable amount of curiosity. Hawking would spend a few years collaborating with various physicists, mathematicians, and cosmologists. Hawking began working on creating an answer to the hot topic at the time: did the universe have a beginning? Carr et al. His work began alongside mathematician/physicist George Ellis in 1965. Hawking's supervisor, Sciama, had previously introduced him to a mathematician, Roger Penrose, in the same year. Together, Hawking and Penrose collaborated on a paper that would further investigate whether Einstein's theory of general relativity would still hold true regarding the nature of black holes. This paper would imply that time would have a beginning in the Big Bang and an end in black holes. Stephen Hawking. It was published in 1970. Photo. An image of the Messier 87 black hole showing for the first time how it looks in polarized light. The lines mark the orientation of polarization, which is related to the magnetic field around the shadow of the black hole. Off topic, I can't wait to see what the James Webb Telescope will bring us. Papers 2. During his years at Cambridge, Hawking would consider other theorems or papers with other fellow students or advisors to see if they could help him further his understanding. In 1972, along with George Ellis, the text, The Large-Scale Structure of Space-Time, was produced, which from then on served as a standard reference in the field. Carr et al. With all this information and knowledge established, the limits of knowing how black holes behave naturally reached a deadlock. Black holes, however, contain space-time singularities, regions where general relativity breaks down, raising fundamental issues about the nature of space and time. Carr et al. Photo, Hawking and Ellis. Papers 3. Because of this deadlock, the solution was to attempt to combine general relativity, the theory of the very large, with quantum theory, the theory of the very small. Carr et al. A colleague, Jacob Bekenstein, had inspired Hawking the idea that perhaps black holes do emit something. At the time, black holes were thought of to never emit anything. There had been papers published by other scientists in the past that more or less said, maybe black holes emit something? Originally, Stephen thought that this proposed idea to be impossible. As mentioned, black holes were believed to not emit anything, which would imply they have no temperature. To pursue this question, Stephen began studying the reactions between particles or fields in relation to black holes. Stephen announced his discovery at a conference in late 1973. Black holes do emit energy. Strangely, black holes that appear to be static also emit particles as well. The work was published under the name Black Hole Explosions? This discovery was not positively received within the community at first. However, the result refused to go away. Carr et al. Along with this discovery raised another question. What happens to matter or information that is sucked into a black hole? If information is lost, this is perceived to violate the laws of quantum mechanics. This is Stephen's black hole information paradox that violates a fundamental tenet of quantum mechanics and has led to decades of furious debate. Stephen Hawking. Forgive me for this, I'm going to read the whole thing. Photo. The most common and incorrect explanation for how Hawking radiation arises is an analogy with particle-antiparticle pairs. If one member with negative energy falls into the black hole's event horizon, while the other member with positive energy escapes, the black hole loses mass and outgoing radiation departs the black hole. This explanation has misinformed generations of physicists and came from Hawking himself. Papers 4. Attempting to understand black holes and the like bring Hawking to a new challenge or two with each step forward he and his colleagues make. In 1981, Hawking proposed to a conference held at the Vatican his theory that the universe began with 4 space dimensions curled up as a sphere, without any boundary, which through a quantum transition gave rise to the universe with 3 space dimensions and 1 time dimension. Stephen Hawking, called the no-boundary proposal. This theory began to intertwine with the idea of cosmic inflation, which is the idea that our universe started with a rapid burst of expansion. Stephen Hawking. Perhaps a more layman's term for this inflation would be considered when the universe kept on exploding. The importance of this combination is that the no-boundary proposal predicts an early state of inflation for the universe. The application of quantum mechanics, along with the theory of general relativity, establishes that The universe is a quantum mechanical system whose observable properties follow the quantum mechanical probabilities, resulting in a renaissance of the field of quantum cosmology. Carr et al. Disability. Hawking became determined to figure out this no-boundary proposal and its interactions with cosmic inflation. He would have spent a great remainder of his scientific career considering the possibilities of this proposal and its validity. It was not a confirmed theory. Despite being without evidence, this proposal grants humanity a greater view of its place in the universe, as well as the history of the universe itself. Scientific importance of the no-boundary proposal is not just a successful theory of the origin of the basic structure of the universe. Perhaps even more important is the impact it has had on how we think about the universe and our place in it. Stephen Hawking. During his career in 1985, Hawking had traveled to Switzerland to participate in a conference. During this travel, Hawking had contracted pneumonia. It was so severe that Swiss doctors had advised Hawking's wife, Jane, to essentially pull the plug on Hawking's ventilator, which would have brought about his immediate death. Stephen Hawking. Instead, Jane had organized for Hawking to be transported to a hospital in Cambridge. The doctors had performed a tracheostomy, effectively removing his ability to speak through his voice. Thankfully, Hawking was alive during a time where computer power was increasing dramatically. Hawking had received help from developers at the tech company Intel, where they created Hawking's signature computer-synthesized voice. Hawking's encounter with pneumonia did increase his dependence on nurses and other medical assistants, however, creating a new and great stress for his family. In 1990, Stephen and Jane Hawking became separated as a result and divorced later in 1995. Still, Stephen had the support of his children and Jane throughout his life and career. Photo. Stephen Hawking in Chicago, 1986. Post-1990 life. Hawking would continue his research while also pursuing publishing books to the public. He would write his current knowledge down in a way comprehensible to any person interested. He had already published a book previously in the 1980s, A Brief History of Time, but published even more throughout his life. Stephen would continue his academic research throughout this time, cooperating with other scientists in research, as well as delivering lectures. Rustan. 2004. In 2004, Hawking announced that there was a solution for the information paradox he had encountered. Originally, Hawking had thought that information that goes into a black hole would end up being destroyed. Stephen in the past had made a scientific bet with colleague John Preskill whether information is destroyed or not beyond the event horizon of a black hole. Hawking's research led him to the conclusion that not all information is destroyed beyond an event horizon. Though he lost. Even with Hawking's discovery, the proposal is not a solid theory and is still debated currently. Afterward. Hawking was bestowed several awards throughout his life for his contributions to science, to our understanding of black holes, and our universe. His final paper was titled Soft Hair on Black Holes, co-authored with a professor, Andrew Strominger, and Malcolm Perry. This was a continuation of Hawking's theory that information is not lost within a black hole. This paper claims that the information is not lost, but is contained within strands surrounding the black hole's event horizon. Stephen Hawking. Photo, Somodevilla. Greatest accomplishment. Now, this is a subjective section, so 2 accomplishments will be covered. Hawking's discovery of radiation, named Hawking radiation, changed the general perception of black holes for his field. It was hypothesized that black holes could emit particles, thanks to information from Zeldovich and Starobinsky. Black holes were thought of to just suck in particles, any energy or information, never to emit any of these entities. Stationary black holes emit information, particles, or energy as well. Because black holes emit energy, they also produce thermal radiation, just like any other star, which also implies that black holes lose mass over time. The process takes an inordinately long time for a solar mass black hole, about 10 to the 67th power years. Small black holes will last about 10 to the 10th power years, approximately the current age of the universe. Carr et al. You can see the actual number for 10 to the 67th power of years. That is 67 zeros right there. That's a lot. Verbally, this is 100 unvingentillion years. Photo. Scientists hope to one day be able to study the radiation of a black hole, which are currently too far away for instruments to gather data on. Greatest accomplishment 2. Hawking's second greatest accomplishment would be the combination of the no-boundary proposal with cosmic inflation. The no-boundary proposal supports the idea of cosmic inflation. The theory of general relativity does not work with the Big Bang, so what would help establish the history of the universe, or even before it? Hawking and his colleagues were able to implement quantum mechanics in a harmonious manner, which brings humanity closer and closer to the answer for the question, how did our universe come to be? The history of the universe depends on the question we ask, he used to say. Carr et al. Photo, Kelly. Controversies. Hawking was not a perfect student or scientist. Hawking admitted to being a late developer and recalled that he was never more than halfway up the class at St. Albans School. Stephen Hawking. Hawking radiation exists with the fact that originally, Hawking denied that a black hole could emit anything in the first place. In fact, he had placed a scientific bet on his opinion, but lost due to his own discovery. Hawking had yet another scientific gamble with Peter Higgs, if the Higgs boson existed. He lost this one as well. And now I have my works cited. These are the websites that I used mainly for collecting information. And then this whole entire works cited page directed for images. And that is the end of my presentation. I hope you have enjoyed it. It's been very illuminating to see Stephen Hawking's life. I just knew that he was a scientist who happened to be disabled, but was also very smart. Never knew anything about him. This whole entire experience has been very enlightening, and I'm going to look forward to reading his books because I'm not going to pretend like I can understand him. If you look at the Royal Publishing Society, the Royal Society Publishing, you will see the formulas and equations that he used. Even though I can plug in certain parts of a formula, I don't completely understand it, so have fun with that. But yeah, that was it. Thank you for listening, and I hope you have a great day.